Hi folks, we're going to take a look at number 11 from page 41. So here we have a function given, and when you take a look at it you realize that this is going to be a polynomial function, because if you were to expand these two you'd just end up getting a fourth degree polynomial expression. So we know this is a polynomial, and they want us to determine the zeros. So essentially what we have is we have a function where some of the work has already been done for us. It's already been factored into two quadratic trinomials, but we want to find the zeros. Hence we want to try to find the binomial, the linear binomial factors. Okay, now here we luckily have two fairly easy trinomials here, so let's see if they're easily factorable or factorable at all. So let's take the first one here. Let's see if we can factor this. So again, we do have a coefficient in front of the x squared, but these are both prime, so I want to try to do this by trial and error. So I know I'm going to need a 2x and an x, and in fact here the only thing that multiplies to 1 is 1 and 1, so I know those have to go there. Can we fit the signs in order to get -1 as a middle term? And we realize that we've got 2 and 1, so if we get -2 and +1, our constant term is correct, and -2 plus 1, -1, our linear term is correct. Okay, so let's do the second one here. So x squared, so we know we have to have x and x, so two numbers that multiply to -4 add up to -3, and you realize that if you take -4 and +1, this fits the bill. Okay, so from here we can see that the x-intercepts can be read directly off the equation. Okay, we also know that this is a fourth degree and it has 4 distinct x-intercepts. Okay, so let's just write them out here. So we've got -1/2, 1, 4, and -1. Okay, now it does tell us to take a look at the graph to see if we have the right answer, but let's go further. Okay, we've got a fourth degree polynomial, and if we look at the leading term, which would be gotten by multiplying the 2x squared and the x squared, we have a positive leading coefficient. So a4 is a4 is positive. I don't really care what it's equal to, but I know it's positive. Okay, so that tells me that the end behavior should go to positive infinity on both sides of the graph. Okay, so in fact, before going to Desmos, let me just sketch what this would look like. Okay, so here we have -1, here we got -1/2. Okay, and we'll need +1, and we'll need 2, 3, 4. Okay, so we know that the end behavior goes from positive infinity from the left and towards negative infinity on the right, and we notice that all these factors have an exponent of 1. So these are all order 1 zeros. So I start at positive infinity. I know it's going to have to go through -1, come back up, go through -2, okay, come back down, go through 1, and then eventually come through 4. Notice how I don't really worry about how far down or up it goes. Okay, I could have been a little more precise. I could specify the y-intercept. So let's take a look at what the y-intercept would be. So 1 times -1, so -1 times -4 is 4, times 1 is 4. So it makes sense that the y-intercept needs to be positive. Okay, so the graph should look something like that, and I'm just going to bring up Desmos here, and we see that it certainly does. Okay, -1, -1/2, 1, and 4. Y-intercept of +4. Okay, now one big difference here is that this minimum here goes way, way down. Okay, but until we get to calculus, we don't have the methods to determine that. So this is perfectly fine for our graph. Okay, that's it for this one.